Hey everyone, a very warm greetings from Edureka. I am Sonal Mittal and I work as a solution architect with a multinational company. So on that note, let me begin with today's session. Let us look at the agenda for today's session. Agenda is to understand the basics of Kubernetes first. What is Kubernetes? In Kubernetes, we have multiple objects, high-level objects. The smallest object that Kubernetes cluster you can work on is a pod, friends. What is a pod? Okay, so we will understand what a pod and why a pod. We will also understand replica set and replication controller. We will understand deployment controller, which is the main thing that we want to look on today. And we will jump on to the practicals. Okay, all right. So I hope the agenda for today's session is clear. Let us continue here. What is the need of Kubernetes, friends? Okay, even before that, if I say containers, the very first thing that comes in your mind, containers. If I say containers, what is it that comes? Which tool comes into our mind? Right, Docker. Right, everyone will think Docker, Mesos, Kubernetes. Right, whenever we talk about containers, it's all about Docker, and Kubernetes, friends. Right? Okay. Friends, containers, tools like Docker, okay, they provide us containers, friends. Using these container tools, we can create containers, we can delete containers. Now, friends, whenever we talk about containers, the only thing or only tool that we all talk about is Docker. But as you all know, I'm sure everybody is aware of it, there are other organizations that also provide us containers like Container D, Cryo, right? We have tools like Rocket, right? We have Linux containers. In addition to Docker being one of the major leader in the market that provides us containers. Okay, so next friends, so these tools, all of these tools like Container D, Cryo, I'm talking about Rocket, I'm talking about Linux, I'm talking about AWS provides containers, then we have Docker which provides containers, right? So these tools, they provide us containers, friends. How do we get containers? How do we get containers? If you see here, as you all were telling, containers are nothing but processes which are fast, reliable, efficient, lightweight. That's right, friends. Okay, but how do we get a container? How do we create a container? So any container tool you take, friends, the very first step is to create a file. We call it as a manifest file. In Docker, we call it as a Docker file. In this file, friends, we write simple instructions as to what we want in our container. As to what we want in our container. Let us say in my container, I want Ubuntu. We all know container is a process, right? Which when runs, provides you your application, right? Okay. It is a separate environment. It has its own network. It's a process. When it is running, it provides you your application. Now on my container, I need Ubuntu. I need Tomcat over it. Okay. And then I have also placed my application code. Okay. So these instructions, I'm going to provide it in a file. Then we build these files. In some of the tools, we call it as a Docker file. In some of the tools, we call it as a manifest file. Okay. In Docker, we call it as a Docker file. We provide these instructions as to what we need in a container. Once a file is ready, a developer or a Docker administrator or the container tool administrator will create an image of it. Will create an image out of it. I hope you all agree with me. Right? An image will be created. Now, what is an image? Image is a static file. It's a set of binaries and libraries that are needed for your software to run. Where is my software? When will my software run? When I run this image, a container gets created. When we run the image, that's when the container gets created. Right? So we don't create a container. Basically, in organizations, friends, we create images. How do we create an image? With a Docker file. This is a three-step process. Any container tool you take it, everywhere you'll first create the file. Out of this file, you will build it into an image. And out of an image, a container will be created. That is why we always say build, ship, run. Build your file into an image, ship it to any location, any library, and run it. Okay, ship it to any environment, your QA environment, your prod environment, pre-prod environment, and then run it to create a container. As you run the image, a container, that is your application, will be available for you to access. Right? Okay. So friends, tools like Docker, being the master leader, market leader, tools like Cryo, Containerd will provide us these images and containers. They provide us mechanisms to write the Docker file, build them into images. And when we run these images, they provide us platforms to run the images to create containers. That is the task of container tools, friends. Shall we call them as container runtime interfaces? In market, we have multiple container runtime interfaces, Docker being the leader in that. These container runtime interfaces provide processes or containers that are isolated, that have their own environment, that are faster. Why are they faster? Because they don't have any underlying dependency of operating system, not required, unlike virtual machines. They are reliable because they can be created very easily and fast. Efficient because resources are allocated to them on runtime. Lightweight, of course, no underlying dependencies. All the required libraries are present in the image. Build them into containers. Scalable, that means if you have to create a virtual machine, okay, on let's say you have a 50 GB physical machine on one particular machine, is on that you will install VMware. You will partition that machine into 5 virtual machines because your application needs at least 10 GB for it to run. Right? You cannot scale further. Right? The amount of resources that are available on your physical machine, only those many virtual machines you can create. Agree? But that's not the case with containers. You can easily scale up those containers to hundreds of containers, friends, because the resources are allocated to the container on runtime, runtime, on runtime. Okay, okay. So that's about an introduction to containers, friends. I hope you have understood. Let us move on. Now, friends, these tools that I just spoke about, these tools like Docker, they provide us they provide us images. They provide us a mechanism to create images, and you can also run this image to create single container, one container at a time, or multiple container, different images, but one at a time. But consider this scenario, friends. I will tell you one scenario. Here it is a problems, right? Let us also take a diagram here for better understanding. Consider this scenario, friends. You have Docker. You're using Docker as a tool to create containers. Awesome. You created one container, let us say a Tomcat container, or let's say my application. You have your application, my app, version 1, which you have deployed as a container. This is one container which is already running in your environment. Now, as per the configuration of this container that you have set, the CPU and memory that you have set for this container, it can manage only 200 user requests. 200 user requests it can manage at a time. My application is relatively new, and at a time, 200 users are only trying to access this application, and it is able to manage it. But after a few months, my application has become very popular in the market. Instead of 2000, I am now getting 1000 users. The requests that I am getting to my container to my application are 1000 users. Will this container be able to process these many user requests? No, right? It will not be able to process. It will give memory out of error, it will give, or timed out error it is going to give, because this container can manage only 200 requests. Only 200 requests it can manage, rest it cannot. What should we do in this case, friends? What will you do in your infrastructure? You will scale up the infrastructure, isn't it? Same thing with containers. You will create more containers, right? You will create more containers. I'll create more containers. Each container can manage 200 user requests, right? Okay. So I will create more containers. My app version 1. Same thing I'm placing here. I'll create total five containers to cater the needs of 1,000 users. Now the request will be distributed to all the containers. All the five containers requests will be distributed, right? So I'm able to manage the user requests easily. And to create these containers, of course, you will use the container tool Docker. Single containers can be created with Docker very easily. Amazing. But now as we progress, let's say there is a sale coming up on my application. Some 3-day sale is coming. So of course users, even if I don't go and check this application, but there is some sale, of course, let us go and check out what's in the sale, right? So instead of 1,000 users, I'm expecting some 50,000 users now. For the next 3 days, I'm expecting 50,000 users. Can you guess the number of containers I will have to create so as to manage 50,000 users request, user traffic? Of course, I will at least need some 200 containers, friends. I will at least need 200 containers, right? To manage these many requests, or let's say 5 lakh user requests you are getting. In real time, these are the number of requests that you will be getting every few minutes, friend. So 5 or 10 containers is not what you will create at the organization level, at a production level. You will manage hundreds of containers, friends. Some thousands of containers a team will manage, friends, right? To be able to manage the user request, right? So how will you create these many containers, friends? How do we create these many 1,000, 2,000 containers? For these, friends, to scale up our containers, that to create, scaling up is secondary. Before that, to create these many containers, okay, we need an orchestration tool. So in order to create multiple containers with one single command, friends, or 5, we have container orchestration tools, friends, in market. We have container orchestration tools. Container orchestration tools. Right? What orchestration means? Orchestration means managing, scheduling, creating, rather starting, deleting your containers at a go, friends. That's what the first task of a orchestration tool. First task of an orchestration tool. Managing, scheduling, starting, deleting your containers, right? And friends, one more thing, please observe here. These containers that I created, do they have different images? They are different containers? No, right? They're duplicates of each other. Replicas is what we call them, friends, in orchestration. Orchestration tool is used to create replicas of an image, friends. Replicas is nothing but multiple containers. Can I say? Replica is nothing but multiple containers of same image. Multiple containers of the same image. So we call that as replicas, friends. Replicas. These few things you need to know, friends. Replicas. What are replicas? I'm sure you would have seen it somewhere, right? If you're working with the container tools. So multiple containers of the same image is called as a replica, friends. Okay. Now, friends, other thing that orchestration tool helps us, scaling up of your containers, scaling up, increasing your containers. Okay, that is suppose, as I was just telling you, in the morning, let's say you have an application, you're working on this application 24/7. In the morning, you see there is a huge user traffic, so you need some 50 containers to run so as to manage those user traffic. But at the night, the user traffic is very low. The users accessing your application is very low. So you don't want 50 containers, even 5 containers are more than sufficient, saving the resource. This auto scaling, increasing of the containers and automatically deleting your containers, scaling up and scaling down of containers automatically based on the CPU utilization of your container. can be done with an orchestration tool. Okay. Now one more thing. Suppose you're creating multiple containers. Will you deploy all these containers on one single machine? No, right? Multiple nodes. Multiple nodes you will take and you will deploy on. Right? Suppose one of the node goes down. What will happen to these replicas? They have to be immediately brought up to. They have to be immediately brought up onto the other nodes in the cluster. So in orchestration, we basically create a cluster also. We create a cluster that is set of nodes. Okay, node. So in orchestration, we work with master and slave set. A master is a machine that will decide what task to be given to the slaves of French. Slaves is where your replicas will be running, friends. Your containers will be running. Suppose one of the replica gets deleted. One of the container gets deleted, friends, because of less resources. Container is deleted. Immediately, the task of the orchestration tool is to bring it up on other server, another node. If the node itself goes away, it is down due to some, it crashed or some of the process is not working, operating system is not working, or due to some reason, the node itself is not working. Immediately, orchestration tool will bring up its replica, one replica, over the other to maintain the high availability of the containers. This is one of the important features of orchestration tools. Friends, Docker single container tools cannot provide these features. These features are provided by the orchestration tools, friends. Okay. Now, if you want to deploy, you have deployed a version 1 of your application. You have deployed a version 1 of your application. Okay. You want to now update, a new feature has come, 2-3 features have come, and a new source code is available. Your Docker admin gives you a new image and asks you to deploy that image into the production servers, and users should not face any downtime. Users should not face any downtime. How can we do that? Friends, orchestration tools will do it for you. They will update the image of the replicas that are already running in the production server without user facing any downtime. Without users facing any downtime. Okay? By using the rolling update strategy, using orchestration tools. Right? So we shall discuss all of this in Kubernetes also. So this was an introduction to what a container orchestration tool can do. See, tools using Docker as a tool, you cannot scale them. Okay, containers can be created. Isolated containers can be created, but scaling them up not possible. That will be done. See here, containers cannot communicate with each other. Containers had to be deployed appropriately. Containers have to be managed carefully. Auto scaling was not possible just with the container tool. Traffic distribution is a challenge when you have single containers. Right? How will the traffic go? To which container should the traffic go? Multiple containers you have created, but challenge, right? Which container should we send the user request? That same thing has been resolved with the help of orchestration tools, friends, which I just explained. And one of the most important or popular orchestration tool is Kubernetes. Kubernetes. Please see here. Kubernetes is a open source container management tool, friends. It manages your containers. It starts your container, deletes your containers, schedules your containers to different nodes, friends. Basically manages your containers, which automates container deployment, scaling, descaling, and load balancing, friends. Okay, as I just explained all these terms here. That is load balancing, distributing the replicas to multiple nodes that are part of your environment or your cluster is what we say. What is a cluster? Cluster is nothing but set of servers, set of nodes, right, in which the deployment should happen. In Kubernetes, we call these nodes as minions, friends. A set of minions on which you have your container tool installed, right, forms a Kubernetes cluster. Forms a Kubernetes cluster. So not only the Kubernetes is not only the orchestration tool, friends. We have other orchestration tool, that is Docker Swarm. Docker Swarm is also another orchestration tool. Now, what is the difference between Docker Swarm and Kubernetes? Then we will talk about it in a minute. Now, please understand. Let's learn more about Kubernetes. Now, I was also telling about Docker. Friends, Docker also gives us a orchestration tool. Docker Swarm. Okay, it gives us also an orchestration tool, which is Docker Swarm, which is comes with Docker itself. When you install Docker on your server, okay, on the host machine, same machine, there will be Swarm mode will be there, but by default it is inactive. If you want Docker to work as an orchestration tool in the Swarm mode, you have to activate it. You have to initialize the Docker. It also performs the same orchestration activities like Kubernetes. Kubernetes is another tool, okay, which also performs the orchestration activities. Both are orchestration tools. What is the difference? One major difference: Docker Swarm will orchestrate only Docker containers. Only Docker containers. Kubernetes, on the other hand, is advantageous, friends, because it can orchestrate any type of containers. Any type of container, right? It can orchestrate Docker containers, it can orchestrate cryo containers, it can orchestrate container D, any container runtime interface you take, Kubernetes can orchestrate the containers. That is the major difference between Swarm and Kubernetes. Both of them provides the same features, that is load balancing. Both of them provides the same features: load balancing, rolling update, scaling, and high availability. Every orchestration tool you take, friends, they will provide you all these 4 features. But Docker Swarm will work only with Docker containers. It can only manage, orchestrate only Docker containers. Kubernetes can manage any type of containers. Now, friends, what is the difference between Docker Swarm and Kubernetes? Docker Swarm basically is very easy to learn. First thing, in this, both of the cases you have manager and master, or master and slave setup. Okay, but here in Swarm, manager will also take the workload. So why are we talking about workload? That is distribution of the replicas, distribution of the containers. Okay, so as we create a manager and worker setup, architecture of the orchestration tool is creating a master node, and you are having multiple slave nodes connected to them. Okay, slaves are connected. Now, friends, these slaves are connected to the master. Master will allocate work to them, give containers to them. 2 containers of Tomcat running here, 3 containers of Nginx running here, 4 containers of HTTPD running here. The task of the slaves is to manage this work. In Kubernetes, master will not have any containers running on them. Okay, it will just allocate the task to the slaves. Whereas in Swarm, master will also have the containers, let's say 4 containers of HTTP. Masters also will have the workload, right? But in Kubernetes, master will not have any workload. It will just allocate the task to the team members, that is to the slaves. Okay, next, friends, to set up your Kubernetes, friends, you will need a high configuration machines. You need at least 4 GB. Okay, to set up your Kubernetes cluster, you will at least need a 4 GB RAM and 2 CPU core, friends. Okay, if you have to do the setup for Kubernetes. Whereas Docker Swarm can easily be managed even on 1 GB for practice purpose. Okay, there's no issues there. All right, Kubernetes, friends, does not have a container network interface. Docker Swarm, if you see, on the other hand, comes with its own network interface, that is Docker 0. Here, Kubernetes does not have any container network interface. So you will have to do the setup. We have to set up the network in Kubernetes cluster, friends. What is K8S? It is a short form of Kubernetes, friends. Right? Between K and S, there are 8 characters. That is why short form K8S, just for your information. Okay. No container network interface. There is no container runtime interface. We have to install the required container tool also. Everything we have to do in Kubernetes, friends. So its installation is little tricky. I'm sure you all agree with me. Docker Swarm, very easy. Okay. All right. So we have to set up which tool we want. We have to install. See, this is an advantage here, friends, not a disadvantage. The reason is Kubernetes commands will remain the same, friends. Let us say there is a command kubectl, friends. Kubernetes command starts with kubectl. Okay, kubectl create 10 containers of Tomcat. 10 containers of Tomcat. Okay, this is the command that you will give. Let's assume algorithm only I'm showing here. Now container, from where are you going to get? Whatever runtime interface that you have downloaded, that container will get created, right? So here I will ask for Docker. Let's say I have installed Docker. So Kubernetes command remains the same. kubectl created 10 Docker Tomcat containers create. Tomorrow, let's say you change your organization, you go to a different organization. There they are not using Docker. In fact, they are using Cryo, let's say. Okay, they're using this particular tool, container tool. You will give the same Kubernetes command. You will give the same Kubernetes command. kubectl created 10 containers of Tomcat, whatever is the image of it. Kubernetes will take care of creating the Cryo container this time. Your Kubernetes commands remain the same. That's an advantage why many organizations are opting for Kubernetes over Docker Swarm. Though Docker Swarm is easy to run, easy to work, but Kubernetes, on the other hand, is advantageous because it can use any kind of container. Tomorrow, let's say any other container tool comes in the market and becomes quite famous than Docker. Of course, we would want to switch our runtime interface to that particular tool. My Kubernetes commands remain the same. Kubernetes can orchestrate even the new container tool also. Okay, friends. So these were some of the advantages of Kubernetes. So previously, Kubernetes is a tool of Google. Now it has been taken by CNCF. Okay, it will create, manage n number of containers, friends, depending upon the runtime interface that you have on your multiple nodes, friends. So here are the features which I already explained you. Okay, self-healing, if in case it breaks, it joins back. Horizontal scaling, right? It can automatically scale up, scale down the containers. You can maintain encrypted data, secrets, config management can easily be done in Kubernetes. Batch execution can be done in Kubernetes. You can roll out your deployments using rolling update strategy and roll it back. Storage volumes, persistent volumes is used in Kubernetes and bin pack. Next, what is an architecture of Kubernetes, friends? Kubernetes architecture, friends. Let's understand Kubernetes architecture first. For that, I will make use of this diagram here. So let us go to Kubernetes website itself. Okay, 1 minute. Just a second, friends. Here, let's go. Yeah, so here you have the architecture of Kubernetes. I'll come to the features, friends. I'll come to the features in a minute. Okay. Let us open this. Understand the architecture. Everything will fall in place, friends. Okay. So let's understand what is Kubernetes cluster. Kubernetes cluster, first of all, friends, is nothing but a set of nodes and a mask in which you have one master machine and you have multiple slave machines connected to it. In a Kubernetes cluster, friends, you will always have one main master machine, okay, to which other slaves are connected. Now, on the master machine, friends, you will have 4 components, friends, important components. API server, this is the first component. Scheduler is the second component. Controller manager is the third component. etcd is the fourth component. Fifth one is cloud controller manager, which is optional, friends. It is used when you are trying to access the Kubernetes cluster through a cloud provider. Like if you know AWS, Google Cloud Platform, they also provide Kubernetes, okay, as a cloud, as a service like GKE, AKS, EKS, right? So that is when cloud controller manager will come into picture. It's optional, okay, it's not mandatory. Now, friends, as a user, you will send a request to API server. API server will take the request sent by the user, and on all nodes you have you will have something called as a agent process called as kubelet. As the API server gets a request, let's say to create 2 Tomcat containers, that is, you are an admin and you have sent this request to Kubernetes master machine. Create 2 Tomcat containers. You will not mention where you want to create those containers, let us say. So you have scheduler on the master machine that actually watches the API. It tells API, hey, you got a request, right? Create it on node 1. Create it on node. So it is a task of the scheduler to decide where the request should run. On node 1, it will decide. Okay, done. That is scheduler. As a user, you will always talk to API server. Once scheduler decides where the replicas have to be created or containers have to be created, API will send a request to that kubelet. Kubelet will understand, okay, I have to create containers. API server will send a request to kubelet to create 2 Tomcat replicas. Okay, kubelet will take help of the container tool Docker in our case and pull that image and create the replicas on it. Send a response back to the API server. After that, the third module that we have, component that we have, is controller manager. Controller manager is responsible to make sure that these 2 replicas are maintained on the node. High availability of the replicas on the node. Controller manager will take, at any given point of time, 2 replicas have to be maintained. Then etcd, what is etcd? It's a key value store, friends, on the master machine. It maintains the complete information about your cluster. How many nodes do you have? How many replicas are running? How many applications have to be deployed? Everything will be there on etcd, friends. Okay. Now, the Kubernetes proxy here is responsible to distribute the traffic based on the network rules across the nodes, friends. Okay, kubeproxy will be used. So this is the architecture of Kubernetes, friends. If you understand this, working with Kubernetes is very easy. Okay. Now let me directly jump on to the practical, friends. So you have understood the architecture of Kubernetes. So here, friends, I have started 2 machines, 2 Ubuntu machines, friends. Okay. 2 Ubuntu machines I have started. On these machines, if you see, I've already created a Kubernetes cluster. Okay, in this cluster, I will execute the commands using kubectl. That is a process that basically, that's a client process that sends your request to the APIs. Kubectl get nodes means it will get the number of nodes that are part of your cluster, Kubernetes cluster. I have 2 nodes, friends, kube master, kube slave. Okay, one is the master machine where I'm executing the orchestration activities. Another one is the slave, friends. Nothing is there on this slave. Only Docker is available. Okay. Now, friends, first thing, how do you create a pod? How do you create a container? In Kubernetes, we create a container. Okay, container C1, let's say, of nginx type. This image you are going to get it from Docker. This is Docker image. But friends, in Kubernetes, we have another layer over your container, and it is called as a pod, friends. Pod is a layer of abstraction over your container. In Kubernetes, you will never create a container. You will create a pod. A pod in turn will create a container for you. Remember. So in Kubernetes, we say creating pods. That means creating a container. I want 10 pods. That means 10 replicas of container. Okay, a layer of abstraction. All right. Maybe why a pod then? Why a pod? Because container runtime interface can change in Kubernetes, right? Kubernetes command should be same. In Kubernetes, you will give only the single command kubectl create pod. Let's say Tomcat pod. This is not the correct command. This is just an English algorithm. Create a pod of Tomcat. It will remain the same. This command will remain the same. Based on the container runtime interface that you have on the master machine, that container will get created. Isn't it, friend? Okay, so Kubernetes command is same. Kubernetes will create a pod. It's the task of the pod to check which container tool does it have in the cluster. Create that container. So user does not have to bother which type of container to create, right? User will just create a pod. Now, how do we create a pod? Let us see here. Kubectl, first command for the day, friends. Kubectl pod, give a name to the pod. Okay, I will give the name as pod1. Kubectl run. Run is the command. Just like in Docker, you create run, you use the run command to create container, right? Same thing. kubectl run pod1. Which image you want on the pod? I want the image, let's say Nginx image. Now, here you are not mentioning anything, whether it is a Docker image, which image, we don't have to care about it. Kubernetes pod object will take care of it to create the container. Please observe, here one pod has been created. One pod has been created with the name as pod1. Nginx is just a web server. It's a web server. Okay. Now let me show you what actually happened when you created the pod. Let me show you what happened when you created the pod. So kubectl describe pod, which pod1, name of the pod. See here, these are the events that occurred. First, you sent a request to the API server using the Kubernetes command. Which process took care of it? Scheduler decided where should the pod run on the slave, decided the slave. Then kubelet process on the slave pulled the image, took help of Docker to pull the image, successfully pulled the image, created the container in pod1, started the container in the pod1. Which container? You want to see those details? Let us see that also inside the pod. Same describe command only. I will give less. See here, pod1 got created here on the node slave because scheduler decided it to be on the slave. Right now it just got created. Okay, it is in the running status. Pod1 container name, image Nginx, image ID. No port mapping done so far. Okay, got it? All right. So this is how you create a pod. Now you know how to create single pod in Kubernetes. If you want to create 10, 20 pods, and that too you want to create for your application, you want to deploy your application. For that, we have another object in Kubernetes called as deployment fridge. Let me talk about it. kubectl explain deployment. So friends, if you want to learn what a pod is, what deployment is, what replicas are, replica set is, just use this explain command of Kubernetes. Hey Kubernetes, explain me what is pod, what is the deployment. Please see here. Okay, deployment enables you to update your pods and replicas. It allows you to create pods and multiple replicas of the pod, friends, basically. Okay, deployment. And in order to create a deployment, you have to give 4 information, friends. That is code library that is needed in Kubernetes to create the deployed API version. What kind of object are you creating? Name of the deployment and the specifications. That is, in your deployment, which image do you want to create the container of? How many containers do you want to create? Should the containers be created at the same time? Should the containers be created one after the other? What is the utilization of those? The limitations, resource limitations of those containers. We will define under specification section. You must be thinking, where should we give all these details, Sona? Deployment, okay, we are talking about deploying an image, okay, on multiple containers in the cluster. But how do I provide these details? Metadata details, specification details, where do we provide? Friends, in Kubernetes, we write something called as manifest file or object definition files. We write it in YAML format. Okay, Kubernetes object definition files, friends, they are written in YAML. Let me show you one such file, vim deployment.yaml. Okay, I'll write down one. It consists of 4 sections, friends. Any YAML file. Even to create a pod, you will have to write a YAML file. Okay, so the first thing is API version you will do. That is, in programming language, we have packages, right? To work with existing methods, we pull the package, we import the packages. Similarly, in Kubernetes also, you have to import a code library for the object that you are creating. We are creating a deployment object. So here API version is apps/v1. Okay, apps is a code library that will help Kubernetes to create an object of kind deployment. Deployment consists of following things, friends, if you are confused. Okay, that I directly jumped from pod to deployment. Not to worry. Pod is what? One single container. In a pod, you will have one container only. If you want to create multiple pods, friends, multiple pods of the same image, C1, C1, C1. Okay, you and also friends, you want to manage these replicas. They are called as replicas. I hope you remember it. Multiple containers of the same image, replicas. You will create a deployment, friends, deployment. And another advantage of deployment, it's also called as replica set. Creating multiple replicas of a container is called as a replica set object, friends. Replica set. Deployment is just like replica set. The only difference is you can also update an image, update the image version. Right? You can deploy new images with the help of deployment object. Okay, that's the advantage of creating a Kubernetes object called deployment. Please observe deployment. Kind of object that I'm creating is deploy. After this, you will give metadata. Metadata. In metadata, you will give the name of your deployment. I will say my deployment. I'll give my nginx. I'll do an nginx image deployment. Okay, I'll give my nginx. Now after this, you will give specification section. Specification as in pods to be created. Which pods have to be created? Using which image the pods have to be created? Which application do you want to deploy? Which applications do you want to deploy is the question. So you will provide a template here. You will provide a template over here under the spec section. First, you will tell Kubernetes, hey Kubernetes, I need 3 replicas or 10 replicas. So replicas is what you will give me. Replicas, I'll say 3 replicas I want to create. Kubernetes will ask, replicas of what? Replicas of what? So here you give the template that, hey Kubernetes, create pods, friends. Template, you give the pod template. Metadata, again, metadata of details about the pods. That is, what will be the name of your pod? Name of your pod. So I will say my pod. Okay. And after this label, we will also give a tag to the pod. Okay. Labels. Here you will give the labels as type is equal to web server. That means all the pods, we are going to create 3 pods. All the 3 pods are going to have a label called as web server. Right now, just assume that label is nothing but a common tag to all the pods created as part of this deployment. For example, you all are students of my webinar. For all of you, the common tag is Sonal Mittal being the instructor for this webinar. Similarly, as part of this deployment, 3 pods will get created. The tag is web server. Okay. Next, after this, under labels, at the metadata level, you will provide specifications of the container. Right inside the pod, what is there? Another specification, that is container. Containers. Which containers do you want to create? I want to create an image. I want to create one container with an image called as nginx. And this time I will take the version as 1.7.9. This is the version, specific version of image that I am choosing. Okay. For this deployment, 3 pods should be created. In the pods, there should be a container with the image nginx 1.7.9. And name of my container is going to be C1, friends. Okay, anything you can give. Okay, friends. Make sure specification is at the same level of metadata. Name of the pod, labels. Okay, done, friends. Now, friends, here I will give one condition also. Why to just create it? Why to just do an easy job? Let us make it little complex. I will give a condition here under replicas. What we will tell to Kubernetes, hey Kubernetes, do a search in the cluster. Do a search in the cluster. If in your cluster right now you have any pods, yes, there is a pod. One pod is available right now. On that pod, if the label is web server, is the label as web server? No, right? My pod does not have any label. If there is a pod in your cluster with the label as same as web server, consider it part of my replica. Consider it as part of my replica. So already there is a pod with web server, let's say. So number of replicas to be created 3. Already 1 is there in the cluster. So with this deployment, I have to create just 2 more replicas. I just have to create 2 more replicas because one pod is already available. One replica is already available with the same label. So I'm adding a condition here. Selector. In selector, you will give a condition here, match labels. Match labels. That is, match the label. Which label? Type. I have given a label, right? Label for the pod. Type is the label. Web server. Go and check. Hey, so before creating the pods, we are asking Kubernetes to go and check in the cluster if there are pods with the same label as that of web server. If there is a one, then just create 3 minus 1, 2 pods. If there are no pods, with the same tag not available, with the same label, it's not available, then here is the template. Here is the template. Create the pods, 3 pods you create this time. Just a condition, just if condition. If there are pods with the label type is equal to web server, select them and rest you create. Okay, all right. You can read about it. Selectors and labels. Now this is my deployment here done, friends. What does this deployment do? It's a high-level object, friends, in Kubernetes. As you will see, when I will execute this deployment file now, friends, deployment. What will this deployment do? This deployment will first create a replica set. Replica set is an object in Kubernetes. That is number of multiple replicas it will create. That is 3 will be the 3. Replica set will maintain 3 replicas. In addition to this, it will create pods. 3 pods. 3 pods will get created of the same image. Of this image, 3 pods will be created. So deployment is a high-level object which in turn creates 2 other objects in Kubernetes. Replica set and pod. So let me execute this and I'll also show you a shortcut for it. Okay. Now how do you create this? How do you create this deployment? You will use a command kubectl create -f deployment.yml. Okay, take that. Deployment has been created. Now observe the objects which got created. kubectl get all. So from where are we getting this all the details? From the etcd database that we have on the Kubernetes. See here, 3 new pods got created. Containers are being created. Okay, and one deployment got created. One replica set also got created. If you want to create multiple replicas of an image, you will use replica set. Pod is what your container will be there. Deployment is same as replica set, just created containers. So what is the advantage of using deployment? I have not given Rahman for providing pod details for accessing your service, containers from the external world. We have another object in Kubernetes called a service, using which we can give pod details. Okay, all right. Let me just rerun this command to see if the containers are up and running. Pods are up and running. See, all the 3 pods are up and running. Now, friends, let me do a rolling update. Basically, deployment is for what? You have deployed a version of an image. So, kubectl describe deployment. What is my deployment name? My nginx. See here, I should have given less. So if you see here, this is the image which got updated. This is the image which got updated, right? Now let us run a command. I'm going to now run a command, kubectl set image of my deployment. Okay, deploy. What is the name of my deployment? My nginx. Okay, container name C1. Right now it had an image nginx 1.7.1. I want to update it to nginx 1.9.1. New version of the image I want to update, friends. I want to change the image on my deployment. A new code has come up, new version has come up, I want to update it. You will observe that the pods will get created, okay? The pods will get updated with the image immediately, okay? One after the other, friends, one after the other. So please observe here. So deployment has been updated, kubectl get all. See here, the previous running containers have been deleted. They will get deleted. One by one, new pod will get created. One after the other, a new pod will get created. Before that, see here, previous replica set, this one. 3 desired count. Okay. First, what Kubernetes does here, when we are talking about deployment, deploying a new image, Kubernetes will first create one container first, one pod it will create with the new image version 2, let's say. Okay, once it is up and running, it will, from the previous deployment, it will reduce. Okay, it will become 2 after this. Okay, and it will reduce the one of the, again it will increase the new replica here with the version 2. Here in the previous replica set, older version will be deleted. Older version will be deleted. Again, desired count will increase for the new replica set. The previous replicas will be deleted. Rolling update one after the other. See, we have version 1, version 1, version 1. 3 replicas are available. I sent an image to update. Okay, I sent a request to update the image, version 2. What Kubernetes will do? It will first create one new replica, as you see here. Created one new replica, version 2. It will bring this down once it is up and running. Once the status changes to running, one of the previous replica will be down. 3 replicas in the cluster. User requests are still managed. Now it will again create one more replica with version 2. This will be deleted once this is up and running. Again create one more replica with version 2, delete. This is how rolling update happens. Let us see now again. It must have updated all the replicas. Can you see here? Previous replica set deleted everything. Just few seconds ago, new replica set got created with 3 new replicas of the latest version. You can still check it. You can check it. You can check on the pods. Let us check the pod. kubectl describe pod. What is the name of pod? Let us take this name. See here, version has been changed. Image version has changed. This is deployment friend. Kubernetes deployment object friend. You can also execute the log. You can check the log of your containers, okay, on Kubernetes friends. If a pod is evicted from a node, all the corresponding containers are also evicted, right, along with their logs. Okay, thank you so much, friends. Bye-bye, everyone.